All right. So thank you so much for joining us once again for this session. This is the last session that we are going to have, and it's basically on correlation and regression analysis. It's part of a broader category of a branch of mathematics, if you so to speak, mathematics or statistics, where we call it measures of association. Okay, measures of association. All right, sorry, and we deal with how variables relate with each other. Okay, so how is one thing associated to the other? And basically that is what we are going to do as far as this course is concerned. And you would see more examples of this, and you see how interesting this would be. Okay, so you look like, as I said, what we normally or generally term as measures of association, and we will identify how two variables will relate with each other. Okay, and then we extend it further to regression analysis, where we begin to make predictions on how the values of one variable can be used to predict another variable. Okay, so basically what we are going to do is that you should be able to draw and interpret what we call a scatter plot. We should be able to calculate and interpret what we call a simple correlation coefficient. You should be able to identify whether a correlation is significant, and then you should also be able to interpret simple linear regression equations for some set of data, understand the assumptions behind regression analysis, and we're going to use Excel. Yeah, we're going to use Excel. Okay, and determine whether a regression model is significant or not. All right. So I think we can start. Very good. Yeah, so this is your reading list. You can always check it out and see, get more information about what we are doing today. Okay, so number one, let's start. What is a scatter plot? So when we talk about a scatter plot, a scatter diagram, okay, the scatter diagram is one way of a graphical approach to help us identify the relationship between two variables. So for instance, if I have two variables, say age, okay, and let's say physical strength, okay, I want to ask, is there a relationship between age and physical strength? Do you think there is a relationship between age and physical strength? Can anybody help me? You can either type or you just raise your hand. And let's see if I can call somebody to help me. Okay, so yes, the person who said yes. Okay, Janet, can you help us? That'd be great. All right.
Okay. Age.
Hello. Oh, okay, Janet is off. Let's see. Eugenia. Eugenia, can you help us? Yeah, I think you can speak.
Yeah, so
Yeah, yeah.
yeah, I think age and
Discuss.
strength
Yeah.
can be can be related because they say the younger ones we are stronger than the older people, and
Okay,
it's
so hold
true.
on. Let's say that if your age increases as you grow older, do you get stronger or you get weaker physically?
I think it's like a care something. You
Okay,
you
so
grow strong to
let's
a
say
point where
between 0 to 20.
0 to 20,
Yep.
your strength increase.
Your strength
You become
increases as your
stronger.
age increases. So we can have a relationship between your age and then the strength, right?
So,
Very good. And okay, that's great. But we will talk about the other parts. And that was a very good example that you gave. Okay, so we can measure some of these things with we can measure some of these things using correlation analysis. And for now, we are interested in a linear association or a linear relationship. A linear relationship in the sense that you want to see if one variable is increasing, what is the other one? What is happening to the other variable? Is it also increasing or is it decreasing? Okay, so you will test when one variable is increasing and then the other, maybe the other variable will also be increasing. Or perhaps when one variable is increasing, the other variable will be what? Reducing, isn't it? So correlation analysis is one way that is able to help us measure the strength or the level of association between these two variables. Okay, and what we are concerned about is basically the strength of the relationship, but not a causal effect. Okay, we are interested in correlation, but we are not interested in causality. Okay, and what I mean is that sometimes two items can be related, but it doesn't necessarily mean that one caused the other to occur. Okay, maybe age and strength can be related, but it doesn't mean that your strength came because of your age. Okay, so we would explain that much into detail when we move on. All right, let's move on. So there are several relationships, and this is a typical example of a scatter plot. And of course, you're going to learn how to do a scatter plot, right? This is a typical example of a scatter plot, and as you can see in this scatter plot, we have you see that when I decide to draw a line through this, okay, I see a sense of a linear relationship, okay. And this scatter plot also, when I draw a line through it, I see it looks like a curve. So that's a curve linear relationship. This is also a linear relationship, right? This also looks like a curve, more like the line, more like an exponential curve. So also more or less a curve linear relationship. Now, you're not going to deal with this, okay? You're not going to deal with this, but we'll be dealing with more of linear relationships. Okay, so that is what we are going to do. Now, relationships can be strong and then relationships can be weak, isn't it? This time I need someone to help me. All right. If we're Asantua, are you there? Let's see. Okay, someone to volunteer. I think that'll be fine. So relationships can be strong and then relationships can be weak, right? Okay, Eugenia, thanks. All right, Eugenia, let's see. You have friends, right?
Yes, sir.
And then you have best friends, isn't it?
Yes, sir.
So what it means is that the way you relate, and you have acquaintances, right? The way you relate with your friends is a bit different from the way you relate with your best friends, and it's a bit
Yes,
different from the way you relate with your acquaintances, your hello hi kind of people, isn't it?
yes,
So there
yes,
are certain people that you would have a stronger relationship with, and then there are certain people that, of course, there exists some level of relationship, but they are very weak, right? And
yes,
there's also another.
yes,
So when you advance, you realize that you see the various types of correlations, and as I say, we have the strong relationships and then you have the weak relationship, right? You would realize that the scatter plot alone doesn't give us a very clear picture of what the relationship entails. Okay, so
yes,
when we do that, you would see that you're going to have certain ways of identifying how strong or how weak a relationship is. Okay, so the scatter plot gives us an idea, a picture of how the relationship is, whether it's a positive or it's negative. Okay, but in really determining how strong or how weak it is, there are other surest means of testing. Just as we say that duty lies in the eyes of the beholder, there's also the thing that says that sometimes someone can see a scatter plot and can conclude that it is strong. Meanwhile, another person can also see it and say that it is weak, right?
Yeah.
But when there are certain other ways of testing the strength or the weakness of a relationship, all of us can look at it and then conclude that this is strong or this is weak. So we're going to move on to that. I hope that is okay. All right, thank you. Okay, so we move on. Then there is also the situation where there is no relationship at all, right? There's no, so we don't see any pattern, whether any linear pattern. Okay, this one for instance, and then this one for instance. Okay, all right. So the one way of determining the strength of a linear relationship between two variables is by using the correlation coefficient. Okay, the correlation coefficient. So the correlation coefficient measures the strength, okay, of the association between the variables. Once again, correlation coefficient measures the strength of the association between the variables. Okay, now we can have the population correlation coefficient, which is denoted as rho. Okay, this symbol here that looks like a P is not a P. We call it rho. Rho is a Greek letter. Okay, and then we have the sample coefficient, which is R, which is an estimate of rho in case we don't have access to the entire population. And then we are estimating the population correlation coefficient using the sample. All right, just a second. Okay, so welcome back. So basically, that is what we have, the population correlation coefficient, and then the sample correlation coefficient, which is actually an estimate of the population correlation coefficient. Now, all of these things are used to help us to measure the strength of the linear relationship. Okay, and the correlation coefficient is unit free. Okay, that's one thing, the first thing that you need to understand. When I say unit free, it is not measured in any units. So, for instance, weight can be measured in kilograms, or no, mass can be measured in kilograms, weight can be measured in newtons. Currencies measured in the kind of currency, CD, dollar, any other currency that you want. Distance can be measured in kilometers or meters, or yeah. But the correlation coefficient is not measured in any unit. So it's a dimensionless measure or unit free. And it ranges between -1 and 1. Now, this is very important. Okay. Correlation coefficient is a value that ranges between -1 and 1. The closer it is to -1, the stronger the negative linear relationship. The closer it is to +1, the stronger the positive linear relationship. And the closer it is to 0, whether from the left or from the right, the weaker the linear relationship. This is very important for us because sometimes people interpret these coefficients wrongly, okay, and it can affect us. So let's take note of these interpretations. All right. So if the correlation coefficient is 1, either -1 or +1, it tells you that we have a perfect correlation. Okay, so this is a perfect negative relationship and a perfect positive relationship. It means that if for every unit change in X, there's a corresponding unit change in Y. So X changes just as Y changes, or variable 1 changes just as variable 2 changes. Now, this X and Y are the variables. Okay, so it could be anything. It could be any other variable that you want. Okay, so all of those things are important. Okay, now so you can have a perfect positive relationship or a perfect negative relationship, right? So for instance, if I slap you once, you slap me once, you also slap me back. If I slap you twice, you also slap me back, right? But that is just by the way. But the relationship can be a perfect correlation, negative correlation, or a perfect positive correlation. And then we also have another one where the correlation coefficient is negative 0.6. This is a fairly strong relationship, right? As you can see. And when you draw a line through that, you see that it's a negative correlation, right? This is no correlation at all. This is a weak positive correlation, and that's a perfect positive correlation, as I've already indicated. Okay. Now, how do we calculate these values? That is where we are. How do we calculate these correlations? How do we calculate these correlation coefficients? And that is where we are going to establish the mathematics that surround correlation and regression. Okay, so the correlation coefficient is a very simple procedure. Okay, so we are just going to use what we call covariance. So the formula for correlation coefficient is basically the covariance between x and y divided by the variance in x and then the variance in y. How x and y move together, okay, with respect to how x moves alone and how y moves alone. And when I talk of x and when I talk of y, I mean the two variables that you are comparing. Okay, it will get to a point where we would indicate x as an independent variable and y as a dependent variable. But in the sense of correlation, and then for correlation analysis, we are not really going to delve into that. We just take x and y as two variables that you're going to deal with. Okay, so basically the numerator, okay, the numerator is expressed in this form. The covariance between x and y is expressed in this form, where you have xi minus x bar, yi minus y bar, all divided by n minus 1. You sum them together, and the denominator is also having this portion, as in it's the same way as trying to calculate the standard deviation, right? And then that of the y variables also giving us that. So when you put all of them together, they kind of cancel themselves out, and you end up getting this relation, right? So you see that finally your eventual formula for determining the correlation coefficient is basically xi, or the x's minus x bar, or the y's minus y bar, divided by the square root of x minus x bar squared multiplied by the y minus y bar squared, of course, all under the square root sign. This looks a bit jammed together, but you see how simple it is when we begin to solve examples that relate to the correlation coefficient. Once again, you would have to give me permission to use Excel. Okay, it's easier to use the Excel to show you, and it's easier to follow when we are doing that, especially in this situation where the lecture is online. Okay, all right. So let's see that we have this example. We want to see whether there is a relationship between the number of commercials and then sales volume. But before we move on, do you think that, let me ask this question, do you think that there is a relationship between the number of commercials that a firm does, okay, and the number of sales that they report? Is there a relationship? Is there a relationship between adverts, right, and then sales? Do you think there is a relationship? Can someone help us? Okay. Yeah. So yes, Maureen, what do you think?
Yeah, so because advertisement is part of marketing, usually it registers in people's minds, and research has shown that advertisement increases sales of a particular
Okay.
product.
So the more you increase your level of advertisement, the more you increase your reach, right? And when you increase your reach, the more people become aware of your product, and the more they buy, right? So, but of course, there are some products like St. Louis cubed sugar and Gary and those other things that do not need adverts to run, right? Because those things are there. And there are some products that the more you even advertise, you don't even get sales, right? But generally, on the whole, um, you see that the more advertisements that you do, the higher your sales volume, and that's why companies will spend millions trying to ensure that they do their adverts, and then they get people to know what they are up to and what they are doing, as much as with respect to their brand or with respect to the product that they are dealing with. Okay, so basically that is it. All right, thank you, Maureen. And you would continue with the information that we have. So I am going to, as I said initially, I'm going to open this one up, and I'm going to put this information in Excel, okay, and then we will use the Excel to solve, and then to see how to test for correlations and how to calculate when it comes to correlations, and then regressions of such nature. Okay, so we have the data here. I'll quickly look at them and enter them in this table. So we have the week, and then we have the number of commercial, and then the sales volume, right? And this is 1, 2, 3. It runs up into week 10, and then of course the number of commercials is identified as X, and the number of sales volume is identified as Y. So we have that. We have this type. Okay, so we have 2, 5, 1, 3, 4, 1, 5, 3, 4, 2, and then we have 50, 57, 41. What else? We have 54, 54. You have 38. You have 63. We have 48. We have 59, and then we have 46. Okay. Now, if we were supposed to draw a scatter plot for this, right? If we're supposed to draw a scatter plot for this, then you see that we would have found something like this. We would have drawn something like this, an XY Cartesian plane, where we have our X value here, and then we have our Y value here, right? And let's see, the X values range from 1 to 5. So let's say that we have 1, right? Oh, we have 1, and then we have 2, you indicate it. We have 3, you indicate that. We have 4, right? And then of course we have 5, and then you also indicate an appropriate scale for this one. I think it ranges from 38 to the biggest is 63. So maybe I can have let's say 30, 35, 40, 45, 50, 55, and so on. So you plot them. So the first one where we have 2 goes with 50. So let's say 30 is here. Let's say 40 is also here, right? Let's say 50 is here, and then we have our 60 also here. So yep, okay, sorry about that. So 2, when we see 2 on the x, that it goes with 50 on the y, so we indicate it as a point. 5 goes with 57, located somewhere here. 1 goes with 41, let's say located somewhere here. 3 goes with 54, located somewhere, let's put it here. 4 goes with 54, also somewhere here, right? Yeah. So 1 goes with 38 somewhere here, and 5 again, 5 value is 63 at the top here. 3 goes with 48. Where's 48? 48 can be here. And then 4 goes with 59, also somewhere here. And then 2 goes with 46, right? Somewhere here. So this point gives us that scatter plot. And you can see that if I should have drawn a line through the scatter plot, I sense something that looks like a positive correlation. That's this like my line of best fit, right? So this is really what we are talking about when we are dealing with the concept of the correlation that and the correlation approach that we are dealing with. Okay, so I hope you get what I'm saying. All right, let's move on. So I can use Excel to actually draw a scatter plot. Okay, I can use Excel to draw a scatter plot, and it's fun. It helps us to do the things that we have to do as far as the data is concerned. Okay, so we can do that. Fine, let's move on. So it will be easier for me to just indicate it this way and go to insert, and there's a scatter here, xy scatter, and I pick the scatter plots, and you can see how they look like. So this didn't come so well. So you have the x y values here, which is the sales volume and the number of commercials here, and this is how the diagram looks like in Excel. But today we are more interested in how to calculate the correlation coefficient. Okay, how do we calculate the correlation coefficient? Let's come back to our formula. Okay, and we are going to take things step by step. So please walk with me. Okay, wherever you are, walk with me. So we see that the numerator says that the correlation coefficient is the summation of the xi minus the x bar, and then the yi minus the y bar, divided by the xi minus x bar squared, multiplied then the yi minus y bar squared. Okay, so what we have here, we are going to first of all calculate the x bar, okay, and then calculate the y bar, which are what? The means. Okay, so let's all calculate the mean of x. So x bar, so let's say averages, right? The averages. So how do we calculate the average of x? It's easier when I'm using Excel, so I can easily find the average of x. The average of x is 3, and then the average of y is 51. Okay, so these are the average values. Okay, now what this one is saying is that for each item, okay, in X, subtract the mean from it. Okay, for each item in X, subtract the mean from it. That means that I'm going to create another cell here and call it X minus X bar. Okay, X minus X bar, where I'm going to subtract every item I have. I'm going to subtract the mean from it. So here will be 2 minus 3. This side will be 5 minus 3, 1 minus 3, and so on and so forth. So I'm going to have X here minus the X bar here. I will lock it and then I will just run it through. All what I've done is just to look at X here and then subtract from the X bar. Okay, where's X here, subtract from this X bar. So 5 minus 3 is 2, 1 minus 3 is negative 2, 3 minus 3 is 0, and so on and so forth. I do similar for Y minus Y bar, Y minus Y bar, and I'm going to have this minus the Y bar also here written nicely, and I'm going to run it through. Okay, no need for you to sum, no need for you to find the average at this stage. We have to take it step by step. Now let's go back to the formula. The formula is saying that for each of the X minus X bar and then the Y minus Y bar that you have calculated, find the product. Okay, find the product. So what it means is that you are going to create another cell, okay, that gives us X minus X bar, okay, multiplied by Y minus Y bar. Okay, and in that sense, you are just going to have this value here will multiply that value here. So 1 times 1 gives you 1, 2 times 6 gives you 12, minus 2 times minus 10 gives you minus and positive 20, and so on and so forth. So we are going to run that also through. So we have the X minus X bar values given to us nicely, right? And I think we are almost through. So once we have the X minus X bar values, what are we trying to say? They said that we should find the sum of all the X minus X bar. Okay, so let me indicate the sum here, the summation here. So is summation of X minus X bar or times 1 times Y minus Y bar. So you put them together, you sum, right? And then what do you get? You get 99. So our X minus X bar is what? Is 99. X minus X bar into Y minus Y bar is 99. So I think we are done with the numerator, right? Let's come to the denominator. The denominator says that we have X minus X bar all squared. We already have our X minus X bar here. So all that we are going to do is you're just going to square that value. So create another cell that says X minus X bar, right? X minus X bar raised to the second power, and it's just going to be this raised to the power 2, or that 1 squared. So 1 squared is 1, 2 squared is 4, right? Another minus 2 squared is 4, 0 squared is 0. You run it through, right? This slide is not part. Then the document says that you should sum all of that X minus X bar squared. So we put them together and then we get 20. Okay, then we do same, right? And we do same, that is Y, right, minus Y bar all squared, right? Y minus Y bar all squared, that is also this with the power 2, and then you run it through. So basically what we have is 1 squared, 6 squared, 10 squared, 3 squared, 3 squared, minus 13 squared, 12 squared, 8 squared, and minus 5 squared. Then what we have here is that you sum. We have what we need to solve our question. Okay, now the formula says that it is the summation of x minus x bar into y minus y bar divided by the square root of x minus x bar all squared times y minus y bar all squared, right? So it is actually, you have to find a denominator, right? So the denominator is x minus x bar all squared times y minus y bar all squared. And then we need to find the square root of that. We need to find the square root of that. And our correlation coefficient will be this divided by that. And what we get is what? 0.93. So that becomes our correlation coefficient, right? 0.93. So let's see if we got it correct. So we found that, yeah, and that gives us 0.93. Okay, so basically the same approach that we went through, but let's say a little bit different approach that the example went through, but you end up getting the same value. So you see that we had the x bar, x minus x bar, we had the y minus y bar, we had the products, and then you have the squared, and then we sum, and then we go through the same thing. So basically the same thing that I have done and have taken you through. So once that we have the correlation coefficient, now we can get our, make sure we have our how do you call it? You can interpret, right? We can interpret to and here, by way of interpreting, what we say is that, of course, there's a strong relationship between, a strong positive relationship between the number of commercials and then the sales volume, right? That is one part. And this positive relationship shows that the more commercials that you do, the higher your sales volume. Before we move on, and I think just have some few minutes. And before we move on, I just want to find out what can you, anybody give me an example of a negative correlation, any two variables that are negatively correlated. You can write them in the chats, and as we move on with the lesson. Okay, you can indicate them in the chat box. Any practical example of a negative correlation, that would be great. But there's also the algebraic approach. Okay, the algebraic approach to calculating the correlation coefficient. Yeah, now my answers are trickling in. Let's see. So someone says that price and quantity demand. Yeah, everybody gives me the demand and supply example. Isn't there any other example that we can have for a negative correlation? Think about it. Apart from price and quantity demanded, is there any other example that we can have for negative correlation? Okay, think about it. Whilst we think about it, I'll just move on. Right, I have an example in mind, but let me hear of yours, and then you see, age and riches. Hey, Albert says age and riches. How Albert? Okay, Albert, I want to hear from you. How is age and riches negatively correlated?
Oh, okay. So I was thinking that the fact that you are grown, or let's say you are growing, doesn't mean you can be rich. Someone can be rich at very tender age, and then another person can also be poor at let's say being a grown up.
So maybe you would want to say that age doesn't necessarily correlate with riches. Okay, but
Yes.
what negative correlation actually means, if you say age and riches are negatively correlated, what it means is that it's like the older you get, the poorer you become. Is that what you're saying?
Oh, not necessarily that.
Exactly. So maybe what you are saying is that age doesn't correlate with riches. Okay, the fact that you are old doesn't mean you are rich, and the fact that someone is young doesn't mean the person is poor. That is how you can see it,
Yes.
but not necessarily that the older you are, the poorer you become. Maybe there should be some level of correlation, but we can't explain that, right? Isn't it? And also someone says age and strength perhaps when you are um above a certain age, right? And let's say 50, the more when you go past 50, and as you are aging, then your strength begins to fall. Investment and interest rates. Foster, I think I have to bring you on for you to explain this. Where are you? Foster, what investment and interest rate, how are they negatively correlated? Yeah, Foster.
Hello, sir.
Yep.
Yeah, so most of the time, companies that invest, they do borrow from the banks, maybe to finance whatever asset they want to invest in.
Yeah.
So when interest rates are high, the cost of borrowing becomes very high. So that leads to falling investment. So when interest rate goes up, investment falls.
Okay, I think that's a very good example. So you are looking at it in terms of investment in businesses, investment in
Yeah,
expansion,
it could
or
be in assets
yeah,
and sometimes bonds.
exactly. If let's talk about assets, right? So,
Yeah,
or let's talk about investment in some real assets. So you are saying that if the interest rate in the cost of borrowing
borrowing becomes very high.
very high, that's
Because
a
at the end of the day, the returns from that investment must help you set off the loan.
a loan.
So when the cost is higher than the returns coming from the investment, it will be very difficult for you to actually borrow and then pay back.
All right. All right. That's very good. Yeah. Yeah. Cool. And thank you. So, and someone
You're
says
welcome.
that wealth and humility. Wow. Okay. Janet. Okay. I mean, yeah. People have very funny examples. I'll give my example at the end of the class. Okay. That is fine. Okay. So let's move on. There are also other ways to. Yeah. I've seen quite some very interesting examples. Eating food and hunger. Wow. Okay. Um, if a train increases in speed, the length to the final point decreases. Okay, well, is it only a train? Anything like vehicle, car? Okay. All right. So this was another way of calculating your correlation coefficient, right? So it's the same way. So you have a table where you have the x values, the y values, then you have the sigma x values, the sigma y. So you sum all the x and then you sum all the y's. Then you have another cell that has x squared and the y squared, and then you use it. So there's nothing. Another way of determining the correlation coefficient can be this approach is also possible. So you see that they have the y, the x, the xy, the y squared, and then the x squared. So we have the sigma y, the sigma x, sigma xy, sigma y squared, and sigma x squared. Either of them would give you an a correlation coefficient that you can use. Of course, we can also use Excel to determine an Excel generated output that helps us to find the correlation coefficient. There is where you invoked solver, okay, you would also see that when you get to that add in, you see what we call analysis toolpack. Analysis toolpack. Okay. When you go to the analysis toolpack, when you add that add in to your Excel and you go to your data, okay, here when you go to data, you see data analysis over here, and under data analysis we have several tests you can do. Even all the things that we've done, hypothesis testing, everything that we've done can be done using Excel. The hypothesis testing, the the z-test, the one sample test, the two sample test, the ANOVA, the correlation analysis, we can easily use the Excel to do that. I think I will leave that one for you to just familiarize yourself, play around with some of these things, and then you would be fine. Now, the last thing that we want to do, and then we close, is the significance test for correlation. Okay, and remember that we are mostly doing a sample correlation. Okay, we are finding the correlation mostly based on a sample. So we want to see whether if the sample shows a relationship, can it be extended? Can we make an inference to the population that a correlation exists? So we have to test the hypothesis. But before we even test the hypothesis, we have to assume that there's no correlation. Okay, before you have evidence to show that a correlation exists, you first have to assume that there's no correlation. So our null hypothesis is such that the correlation coefficient is 0. Okay, no correlation. And then the alternate hypothesis is such that the correlation coefficient is not equal to 0. That means that correlation exists. And the test statistic is identified as this: R divided by 1 minus r squared divided by n minus 2. And it follows a t distribution with an n minus 2 degrees of freedom. Okay, a t distribution with an n minus 2 degrees of freedom, where n is actually the sample size. Okay, so let's look at this question. There was a question that asked us to find the relation between the height of a tree and the diameter of the trunk. Okay, the height of a tree and then the diameter of the trunk. And we found that the sample correlation coefficient was 0.886. Okay, then we are asked whether there is evidence of a linear relationship between the height of the tree and then the diameter of the trunk at the 0.05 level of significance. So in testing our hypothesis, what we are going to first assume is that there's no correlation. H naught is such that P equals 0, and then H1 or HA is such that P is not equal to 0. That means that the correlation exists. Then our alpha is 0.05. Degree of freedom is n minus 2. Our sample size was 8, right? Our sample size was 8 for this one. And then n minus 2, that gives us 6, right? So we calculate the test statistic, which is R, that is sample correlation coefficient, divided by the square root of 1 minus the correlation coefficient squared over 6, right? And that gives us 4.68. 4.68. So you're going to compare this 4.68 with a critical value, okay? And our critical value is such that it is T alpha over 2, okay, with n minus 2 degrees of freedom. So that is what we are going to have. And you are experts at reading from T tables, right? But basically, it's in the same way as we're doing in hypothesis testing, and you can go and check the other videos on hypothesis testing where we look at the T and the two-tailed case. You will see how this one was done. But basically, you want to find out whether the test statistic that you calculate falls within the rejection region or falls within the acceptance region. So you are going to read these critical values on the T distribution table, and then you would find the critical value. You compare the critical value to the test statistic, and if it is bigger in this case, so for this case, you're going to reject the null hypothesis if the test statistic is bigger than 2.4469 or it is smaller than negative 2.4469. So we found out that it is actually bigger than 2.4469. So it means that we reject our null hypothesis and say that there is evidence of a linear relationship at the 5% level of significance. So basically, that is it for correlation analysis, and we can end here. If there's no questions, we can end here. So I'll just pause and ask whether you have some questions. All right, thank you.